Hello students, today I'm gonna solve the given equation by the matrix method. Okay, first of all, it is given two equation and it can be written in the matrix form as it is. Write their coefficient in orderly form 3, 1, 1, 2 and x and y are variables so that you can write here x and y and the constant is here. And this is the matrix form of the given equation. If you are wondering how can we write this into this form, then if you multiply this matrix by this matrix, then you will be get this equation. If you try to multiply this matrix by this matrix, you will get two equations. So it can be written as this form and this can also be written as in this form. Okay, once we have written in the matrix form, then it can be compared as this this equation which can be written as ax equals to b, where a is this matrix 3, 1, 1, 2 and x is xy matrix and b is 1, 2 matrix. Now next step, now you have to find a determinant, because to find the inverse you have to find a determinant. A determinant equals to, this is a, so that 3, 1, 1, 2. A determinant equals to, this can be written as a determinant equals to multiply this and this element 3 into 2 and subtract by multiplying these two element 1 into 1. 3 2s are 6 minus 1 equals to 5. So the determinant is 5. It means that since a determinant is not equals to 0, if a determinant is not equals to 0, then we can find the unique solution of the given equation. But if the a determinant is 0, then that two equation may be coincident or they are parallel with each other. Since a a determinant equals to 0, it is non-singular matrix. So hence a inverse can be calculated. A inverse exists and system has unique solution. And system has unique solution. Now next step, just find the a inverse. A inverse equals to 1 upon a determinant times adjoint of a. You can simply write the formula. A inverse equals to 1 upon a determinant into adjoint of a, and adjoint of a is, I will show you what is adjoint of a. You can write here 1 upon a determinant. A determinant is 5, and here adjoint. What is adjoint here? Adjoint you can find the adjoint of any matrix by interchanging. Here you can see this is the a matrix, and to find the adjoint of a, just interchange these two element and change the sign of these two element. Interchange these two element and change the sign of these two element. It means that in place of 3 there is 2, and in place of 1 there is -1. Here also -1, and in place of 2 there is 3. I have just interchanged the place of these two element and change the sign of these two element. This is the adjoint of a. And if you can also multiply here either, or in the later also you can, in the later equation you have also already find a inverse equals to 1 by 5, 2 minus 1 minus 1, 3. Now it's time to find the x. So x equals to, we can write here a inverse b. This implies A inverse is just we have find here 1 upon 5 into 2 minus 1 minus 1 3, and B is here, B is 1 2, and you can write here 1 2, and we all know that x is xy, so that you can also write in this form x y equals to, and multiply these two matrix, you can multiply here by this rule, multiply this into this 1 upon 5 into, if you multiply these two matrix you will get 2 into 1, 1 is 2, and minus 1 into 2 is minus 2, and also multiply this by this, minus 1 into minus 1 is minus 1, and 3 into 2 is plus 6, or x upon y equals to 2 minus 2 is 0, and minus 1 plus 5 plus 6 is, here you can write minus 1 plus 6 is plus 5, and we already have here 1 upon 5 outside the box. And if you multiply, if there is the constant outside of the matrix box, then you can multiply this by scalar multiplication rule. You can multiply the each and every element by the scalar number. So you can simply write here, or x y equals to, if you multiply these two elements by the 5, 1 by 5 into 0 is 0, and 1 by 5 into 5 is 1 by 5 into 5 is 1. Therefore this implies x equals to 0 and y equals to 1. This is the solution of the given equation by matrix method.